Welcome you all with the next important question in this chapter capacitance. Derive the expression for the capacitance of a parallel plate capacitor. State the factors on which the capacitance of a parallel plate capacitor depends. किस फैक्टर पे ये डिपेंड है और हम एक्सप्रेशन कैसे ड्राइव करेंगे कैपेसिटेंस ऑफ पैरेलल प्लेट कैपेसिटर. ये बहुत इंपॉर्टेंट क्वेश्चन है, 5 मार्क्स का आज तक बोला गया है. वी आर एक्सपेक्टिंग अगेन. तो इसका जो आंसर होगा सिंपली हम पैरेलल प्लेट बनाएंगे और उसमें हम कैपेसिटेंस निकालेंगे. तो फिलहाल लेट अस ड्रा द डायग्राम फॉर ए पैरेलल प्लेट कैपेसिटर. से सपोज ये एक पैरेलल प्लेट है, these are two parallel plates. This is a positive charged plate because parallel plates are consist of two oppositely charged plates. It is negatively charged plate. Say the area of this plate is A and the separation between the two plates is D. आप ऐसे भी लिख सकते हैं, let's consider two plates of area A and separation D and Q be the charge plus Q, and here is a minus Q charge on the plate. Therefore plus Q charge per unit area gives surface charge density plus surface Q charge density, and here charge negative charge per unit area gives negative surface charge density. That you know the surface charge density is charge per unit area. It's a plus Q charge, it's a minus Q charge plate, it's an area A, and I can write sigma is equal to Q over A, and I can write sigma is equal to plus Q over A, surface charge density, and the separation between the two plates is D. Let us consider the electric field at this point. Electric field is this positive plate, electric field is this negative plate. Say suppose E, but you see at this very point ये जो पॉजिटिव चार्ज प्लेट है तो इसका जो इलेक्ट्रिक फील्ड होगा दैट इज अवे टुवर्ड्स दिस. तो यहाँ इलेक्ट्रिक फील्ड इस डायरेक्शन में होगा, लेकिन नेगेटिव का जो इलेक्ट्रिक फील्ड होता है, नेगेटिव चार्ज का इलेक्ट्रिक फील्ड इनवर्स होता है, हर एक साइड से इनवर्स होता है. पॉजिटिव क्यों का आउटवर्ड्स होता है, दैट यू नो ऑलरेडी. तो यहाँ पे ये नेगेटिव प्लेट है, तो इस पॉइंट पे इस नेगेटिव चार्ज प्लेट का जो इलेक्ट्रिक फील्ड होगा उसकी डायरेक्शन भी इसी तरफ होगी. सो द इलेक्ट्रिक फील्ड एट दिस वेरी पॉइंट ड्यू टू दिस पॉजिटिव चार्ज, ड्यू टू दिस सरफेस चार्ज डेंसिटी इज अवे इन दिस डायरेक्शन, एंड same at the same point the electric field due to this negative plate will be in the same direction. लेकिन अगर हम प्लेट से बाहर जाएंगे तो पॉजिटिव यहाँ की तरफ होगा, पॉजिटिव यहाँ की तरफ होगा, बाहर की तरफ होगा इसका, लेकिन इसका होगा इनवर्स. और यहाँ पे हम देख रहे हैं नेगेटिव का इनवर्स होगा और वो पैरेलल जाएगा पॉजिटिव को. सो इसका मतलब है जो यहाँ पे टोटल इलेक्ट्रिक फील्ड ड्यू टू दिस प्लेट and due to this plate are in the same senses, therefore the total electric field will be electric field due to this positive plate and plus Q positive plate and plus electric field due to negative Q plate. So you write here the electric field will be due to negative charge and electric field due to positive plate. I write positive. So you can write it electric field, this electric field due to surface charge density, वो आपको पता ही है, थिन शीट में हमने निकाला. इलेक्ट्रिक फील्ड टू पॉजिटिव डेंसिटी सिग्मा डिवाइडेड बाय 2 एप्सिलॉन नॉट सरफेस चार्ज डेंसिटी. सो यू कैन राइट इट, इट्स मैग्नीट्यूड विल बी दैट इज पॉजिटिव 2 एप्सिलॉन सिग्मा डिवाइडेड बाय 2 एप्सिलॉन नॉट प्लस इलेक्ट्रिक फील्ड ड्यू टू दिस सरफेस चार्ज डेंसिटी, दिस शीट will be also equal to sigma divided by 2 epsilon naught. I repeat again, at this very point electric field due to this positive plate and electric field due to this negative sheet or this negative plate will be in the same direction. नेगेटिव अपनी तरफ खींचेगा और ये पॉजिटिव बाहर की तरफ खींचेगा. नेगेटिव का इनवर्स होता है तो प्लेट के इस साइड में इनवर्स होगा और यहाँ पे पॉजिटिव का तो डायरेक्शन उस साइड ही होगा, तो इस पॉइंट पे जो टोटल इलेक्ट्रिक फील्ड होगा दैट विल बी इलेक्ट्रिक फील्ड ड्यू टू पॉजिटिव प्लेट, पॉजिटिव शीट, and the electric field will be due to negative sheet. The total electric field will be their addition, and you know the electric field due to thin sheet or plate is equal to sigma divided by 2 epsilon naught. You substitute that very value, and after calculating, you get E is equal to becomes 2 epsilon naught sigma plus sigma is 2 sigma divided by 2 epsilon naught. Then E will be equal to, this is the electric field at the point between the two plates. Since wherever there is electric field and there is a separation between the D between two plates, this plus sigma charge, this minus, there is a separation D between the two plates, so there will be a potential difference V, potential V. That V will be associated with E. You know the potential gradient is equal to E, so you can write V will be equal to E into separation between the two plates, separation between the two charges. So you can have the potential V will be equal to E into D. This is another equation that you can have. Second, say suppose this first. Since these are two plates separated by distance D, since there is electric field, so there definitely will be the potential difference. That potential difference V will be equal to electric field into the separation between the two. You can find out it on this potential gradient. That's potential, this V varies with D is equal to E. So I write here V is equal to E into D, then I substitute. And I substitute the second equation in first equation in second, we get V is equal to epsilon divided by naught into D. Since this epsilon is Q by A, so I can write this is Q by A epsilon naught. This D here, sorry, V is equal to E is epsilon into D, and I can write V is equal to, against epsilon I can write Q divided by A epsilon naught into D. This is the expression we get because I substituted surface charge density is equal to Q over E. This is the V that you get, equation third. Now you know the capacitance between the two parallel plates capacitors is equal to, you know the capacitance Q is equal to CV. What this implies, you can write here, capacitance Q is equal to C into V, and C is equal to Q by V. So C is equal to, substitute in this fourth equation, this third, substituting third in fourth, you can get C is equal to Q divided by V के बदले क्या आ जाएगा, this V, you can write Q A epsilon naught to D, that's Q D divided by A epsilon naught. When you write it, this Q divided by Q D into A epsilon naught, Q cancel, so C is equal to A epsilon naught over D. This is the expression for the capacitance of parallel plate capacitor. So C depends upon the area of the plate, C depends upon the separation between the two, and C depends upon the medium, that's dielectric or insulator, between the two plates. So this second part, this is the first part, that's capacitance of a parallel plate capacitor, C is equal to A epsilon naught by D. And second part, state the factors on which the capacitance of it depends. You can write C is equal to A epsilon naught divided by D. So this indicates that C is directly proportional to area and C is inversely proportional to D. And C also depends upon the dielectric or insulator between the two plates. These are the factors on which the capacitance of a parallel plate capacitor depends. So the final expression is this. Now, suppose if we insert the dielectric or insert a dielectric or a medium between the two plates, then what will be the next this? capacitance, the variation in the capacitance C dash will be equal to A epsilon divided by D, and we know epsilon is equal to epsilon naught K, dielectric constant K. So I can write C is equal to A epsilon naught K A epsilon naught divided by D. So this will be equal to K into A epsilon naught by D. So this is equal to this C. So I can write C dash is equal to K times C. If I insert the medium or insulator between the two plates, then the capacitance variation will be the next capacitance, that's the capacitance after inserting slab or insulator. C dash is equal to K times C, where K is the dielectric constant. It can solve this using many factors. So C is equal to A epsilon naught by D is the expression for the parallel plate capacitors when vacuum is between the two plates, and C dash is equal to K times C, where C is A epsilon naught by D is the capacitance of a capacitor when you insert the medium or an insulator between the two plates. This is the expression and this is the question, and you can write it like way. In starting, you can put down a few lines that, like, let us consider two parallel plates, each of area A, and let D be the separation between the two plates. The surface charge density on this negative plate is minus sigma by Q A minus sigma is equal to Q by A, and the surface charge density of the positive plate Q sigma is equal to Q by A. Let us consider a point P, or whatever you put the name here, where the electric field, where we calculate the electric field due to these two plates. You find out the electric field at very point is towards the negative plate. So the total electric field, you can calculate electric field due to positive plate and electric field due to negative plate. After substituting the electric field due to a thin sheet, that is sigma divided by 2 epsilon naught plus sigma divided by 2 epsilon naught. And calculating this, you get here E. Then you find a relation between E and V. And after calculating this V, here, you can calculate the relation between V and capacitance. First, you find the electric field, then find the electric field between E and V, or find the relation between E and V, then find the relation between C and V. Getting the value of V, you can substitute here, and you can calculate the capacitance. Then inserting the medium, you can calculate this very question. So this was the capacitance of a parallel plate capacitor. Now let us consider the capacitance between the same plates connected in series and parallels. Capacitance of a parallel plate capacitor connected in series and parallel. Series combination and parallel combination are two questions. Let's go for the series combination. Let's consider three capacitors. This is C1, C2, this C3 connected in series. C1, C2. Let's consider three capacitors connected in series with the potential difference. Say suppose V, let Q be the charge. In case of series combination, the charge Q remains same in all capacitors, while as V is distributed as per capacitance of each capacitor. ये चीज याद रखनी है बस. थ्री कैपेसिटर्स इन सीरीज जो Q है चार्ज, ये हर जगह सेम रहेगा, डू नॉट वैरी. लेकिन जो V है, that will be distributed according to the capacitance. So this is C1, it will take V1. This is C2, it will take V2. This is C3, it will take potential difference V3. And charge will remain same, Q, Q, Q. So the total potential will be equal to, you can write, total potential V will be equal to the potential in C1 plus the potential in C2 and the potential in C3. Now, these are one of the capacitor. We find the capacitance of this very circuit. So V1 will be equal to, you know, Q is equal to C into V. So V is equal to Q divided by C. So here V1 will be equal to Q over C1 because Q is same plus Q over C2 plus Q over C3. I just substitute for these circuits. Q1 will be V1 will be equal to Q bata C1, V1 be equal to Q bata C1, V2 equal to Q bata C2, and V3 equal to Q over C3. Substituting these, the total V is equal to, so your total V will be equal to Q into 1 over C1 plus 1 over C2 plus 1 over C3. Now, let CS be the total capacitance or equivalent capacitance when connected in series. CS be the equivalent capacitance when three capacitors are connected in series. So CS will be equal to, therefore total capacitance will be equal to CS will be equal to Q divided by V. So you can write 1 over CS is equal to V by Q. Substituting here, I can bring this V by Q here. I get 1 over C1 plus 1 over C2 plus 1 over C3. Instead of V by Q, I substitute 1 over CS. So you can have total capacitance in series 1 over CS is equal to 1 over C1 plus 1 over C2 plus 1 over C3. This is the total capacitance or the equivalent capacitance between the three capacitors connected in series, that their summation, the reciprocal of the capacitance is added up, the reciprocal is added up, then you get the total, that is 1 over CS is equal to 1 over C1 plus 1 over C2 plus 1 over C3. You have only remember this thing, that Q remains the same and V is varying. Then you have to take the total potential. Then this part is this circuit. You apply the capacitance rule. Then you know this V by Q. If C is the total capacitance or the equivalent capacitance, then we can CS is equal to Q by V. 1 over CS. I take the reciprocal of this 1 over CS. It was V by Q. I know V by Q is here. I write 1 by CS. This is the capacitance of a series of capacitors when connected in series. Suppose if there's n number of capacitors, then we write 1 over CS is equal to 1 over C1 plus 1 over C2 plus 1 over C3 plus dash 1 over Cn. So this is equal to 1 over CS will be equal to summation of 1 over Cn. I runs from 1 to n. This is the total capacitance for the or equivalent capacitance of the capacitors connected in series. Now let's have a simple point. If all the capacitors are of same magnitude, if each capacitor is of same magnitude, then you can write 1 by CS is equal to 1 over C plus 1 over C plus 1 over C dash 1 over Cn times. So you can have 1 over CS is equal to n times 1 by C. So your total combination capacitance is equal to n over C. For the capacitors having equal capacitance, you can write n by C. And suppose if you have two capacitors connected in series, then suppose this C1 and this C2, then like this, two capacitors, C1, C2. Then you have a capacitance C1 over CS is equal to 1 over C1 plus 1 over C2. So 1 over CS will be equal to C1 plus C2 divided by C1, C2. So you can write CS is equal to C1, C2 divided by C1 plus C2. For getting the solution, you have to lastly change this reciprocal. And I take the reciprocal here, it's C is equal to C1. So for two capacitors, you have simply the product divided by their summation. If you have two capacitors of 1 microfarad, each of 1 microfarad, then you get the answer easily. You can write 1 into 1 into 1 plus 1, that is 1 by 2 microfarad. So this at the end, जब आप numerical करेंगे तो आपको ये reciprocal वापस मिलेगा, last में वापस लेना है. This is a combination of n number of capacitors in series. And this is when the equal capacitance when the capacitors are of equal capacitance or equal capacitances, then you can have this OCD formula. So now the next question is parallel combination. Now this is a capacitance, and now in parallels. This is C1, this is C2, and this is C3. C3. यहाँ उल्टा है, इतना ही याद रखो, यहाँ चार्ज डिस्ट्रीब्यूट होगा, दिस विल टेक Q1, दिस विल टेक Q2, दिस विल टेक Q3, और जो V है वो सेम रहेगा, इसमें भी उतना ही, इसमें भी उतना ही, इसमें भी होता है. In parallel combination, the potential difference is same in each capacitor, while as charge Q is distributed as per capacitance of each capacitor. बस इतना ही याद रखना है इसमें. Let's consider three capacitors connected in parallels. Let Q1, Q2 be the charge of each capacitor respectively, and in case of parallel, the V remains the same while as Q is distributed as per the capacitance. Like in case of resistors, V is distributed. Here in capacitance as per capacitance, Q is distributed. Therefore, the total charge Q will be equal to Q1. This Q total charge will be the charge in the first capacitor plus charge in second capacitor, charge in third capacitor. So you have in this circuit, then Q is equal to V1C, VC1, Q2 is equal to VC2 because V is same, Q3 is equal to VC3. So Q is equal to V into C1 plus C2 plus C3. This Q by V is equal to C1 plus C2 plus C3. If Cp is the capacitance, is the equivalent capacitance of capacitors connected in parallels, then you know we have formula Q is equal to Cv and C is equal to Q by V. Then Cp is equal to Q by V. Then this Cp is here, Q by V, instead of Q by V, you write Cp. Cp is equal to C1 plus C2 plus C3. This is the equivalent capacitance when all the three capacitors are connected in series, in parallels. So your capacitance is equal to Cp is equal to C1 plus C2 plus C3. That means you have simply take the algebraic sum of all capacitances of a capacitors when connected in parallels. So for n number of your Cp is equal to C1 plus C2 plus dash Cn. So Cp will be equal to summation of items from 1 to n, item 1 to n, Ci. This is the capacitance. The expression for the capacitance connected in parallels. So You conclude that in case of series, there is a reciprocal sum of capacitances, but in case of parallel, there is a direct algebraic sum of capacitances. These three questions are very important. I hope you understood this. Thank you very much.